Alright, problem 212. This is a problem where we use try. Okay, so first let's make a try class. In the try class there is a children variable of 26 corresponding to the 26 letters. There is also a string word. This will be used to save the word. And we can set an empty initializer. And of course we want to make this public. Okay, then the first step is to make a new root node. And we're going to build this try. For each word, in words, we get the root node, then build the try. For each character in this word, we want to see if the child node exists or not. If it's no, then we make a new try node. And update the node. At the end, we want to assign the word to the node. Okay, after that, we build the try node. Then we want to look at the board. Use the try node to search the words. So we go through each row and each column. Here I want to define m and n as the size of the board. And it's the width of the board. And we're gonna search DFS passing the row and column number and also passing the root node. And we're gonna use the board and we're gonna pass answer. Answer is the answer we want to return. Okay, and at the end we return the answer. So for the DFS, it's a void function. We're gonna pass the row, the column, the try node, the board, which is it's a vector or vector, and also the answer, because we need to update that. Okay, first we want to check if the column and the row are out of bound. If it's less than 0 or larger than the upper limit, or we have already visited this node or this cell, then we'll just return, don't do anything. Otherwise, get the character of at this location. By the way, we're passing the root instead of the index as we do in typical DFS. So we're going to check if there's this children node. If it is null, if it's null, then that means we can return. We cannot find this word. Otherwise, we update the node. And then we should check if at this location it has a word attached to it. So if it's not empty, then it's going to be added into the answer. And we also want to reset this word. Next, we're going to do a search of up and down, left and right. Let the new row equals I plus direction of so this is the new row and column, and we use an array to do this. So we define the direction array is equal to this. And this is pretty standard practice, by the way. And then we do DFS with the new row and column, and with the new root, the updated root, word and answer. And by the way, before visiting this, we want to set it as visited, so we let it equal to pound, and afterwards we want to set it backtrack. Okay, that's it. Let's review the code. First, we'll make a try class. It has children nodes. It has a word. Then we define mn to save some hassle passing the parameters. Define a direction array, so we can use later on. Okay, we'll first make a root try. Then for each word, we populate this try tree. So get the root node. For each character, we check if it has a children node. If not, we make a new try node, update the node, and at the end, we set the word as this word. We set the node's word as word. We initialize, so we declare an answer. So this is to set the m and n values, which are the board size. Then for the board at each position, we run a DFS. In the DFS, we first check if the row and column are out of bounds or visited. If not, we set the we get the character, then check if root has this children node. If not, we return. Otherwise, we update the root to this children node and check if it has a word of empty or not. If it's not empty, we add this word into the answer, then reset the word. So next we're going to search 4 directions. Get the row, get the column, and then do a DFS search with the updated row, column, and root node. At the end, we want to backtrack and reset the board to its original shape. Okay, let's run a test case. Okay, so this should be equals. Check. Okay. Run more test cases. All passed. Submit. And passed.